The thought that should follow whenever you're told that least squares method is used to estimate the equation of the regression line is this. We're looking for a line to fit onto the scatter plot such that the vertical distance between the observed value and the predicted values, when we square them and add them together, so we know these are called the residuals. When we square the residuals and add them together, we get the least possible value. And the formula for calculating the constants A and B are as follows. A equals y bar minus B times x bar, and B equals all of this. Now we see here that in the formula for A, B is required. So we calculate the value for B first. Let's work an example. This table is the same as the one that we've seen previously, where we have the mass of a chemical being related to time. We'll first calculate the value of B, which is the regression coefficient. And there is a systematic way of doing this. We set up a table as follows. The x values, y values, x squared values, and xy values. So our x values are 5, 7, 12, 16, 20. Our y values are 4, 12, 18, 21, 24. X squared values, to get this, we have to square each individual x value. So 5 squares, that's 25. 7 squares, that's 49. 12 squares is 144. 16 squares, 256. And 20 squared is 400. xy, to get this value, we need to multiply each x value with its corresponding y value. So 5 times 4, that's 20. 7 times 12, that's 84. 12 times 18, that's 216. 16 times 21, that's 336. And 20 times 24, that's 480. Then we take the sum of each of these columns. So this is going to be the sum of x. That is equal to 5 plus 7 plus 12 plus 16 plus 20. That's 60. Then we have the sum of y. That's equal to 4 plus 12 plus 18 plus 21 plus 24. That's equal to, I'll write it at the bottom here, 79. Then this is going to be the sum of x squared. That's equal to 25 plus 49 plus 144 plus 256 plus 400. That's equal to, and again I'll write it here, 874. And 20 plus 84 plus 216 plus 336 plus 480. That's going to be the sum of xy, which equals 1130. And remember, n represents the number of pairs of values that we have. So 1, 2, 3, 4, 5 pairs of values. So these are our summary statistics. And recall that the formula for B, which is the regression coefficient, is B equals N times sum of y minus sum of x multiplied by sum of y divided by n times sum of x squared minus sum of x all squared. It's worth mentioning that there are alternative ways of writing this formula, and one common way of abbreviated is sum of squares of between x and y divided by sum of squares of x. And that's the abbreviation, although if you write it this way, it doesn't really give you anything much to go on, because this is essentially equal to all of this here. So now we substitute value. B equals 5 multiplied by, and sum of xy is 1136 minus sum of x is 60 multiplied by sum of y, that's 79, divided by 5 times sum of x squared 874 minus sum of x all squared, so that's 60 squared, and this should work out to 1.2. We're writing our answer to 2 decimal places. Calculate the value for the constant a. The formula is a equals y bar minus b multiplied by x bar. So we have what b is. We found b to be equal to 1.22. Now y bar is simply the average of the y values, and x bar is the average of the x values. Y bar then is equal to the sum of the y values divided by the number of y values, which is equal to 79 divided by 5 equals 15. X bar, average of the x values, equal to the sum of the x values divided by the number of the x values, equal 60 divided by, and we have 5x values. This is equal to 12. Therefore, A equals 15.8 minus 1.22 multiplied by 12 equals 1.16. Again, this is the 2 decimal places. And now that we have the values for A and B, we can write the equation of the least square regression line. So again, general formula, y equals a plus bx. So the equation of the regression line would be y equals 1.16 plus 1.22x. And this here is called the regression equation of the line y on x.